details, or we can take it offline after the presentation is over. So I am going to cover really what predictive maintenance is, some of the challenges that customers are facing, and this is really across various industries that we deal with, giving you an overview, very high level of Senseye, which is Siemens predictive maintenance solution, and then kind of wrapping it up with questions and open discussion. I'm Kelli Case. I graduated with a mechanical engineering degree from Texas A&M, and I have an MBA in global management. I've worked for a variety of different technologies out there. So I worked for OSI Soft selling the PI system. So really, that digital transformation, how do companies take that real-time data and turn it into intelligence, experience with those EAM and CMMS systems. So understanding from a maintenance perspective what you guys have to go through in creating work orders, getting it assigned to the right people with the right tools, according to production schedules. And I'm part of the business development team specifically for Senseye. So as you guys know, and especially over the last couple of years with supply chain issues and others, these are some of the impacts that companies are seeing when it comes to just unplanned downtime. It can have a significant cost. It can cause you to have reduced capacity, missed production, schedules or shipments to your customers. So there's really a lot when it comes to unplanned downtime and the impact that it can have, and really where some of the ROI that you may look for and justifications for technology, for automation, for predictive maintenance. For you guys, it's a challenge across the board, right? Not only are you trying to avoid unplanned downtime, but you're trying to make sure that your equipment is functioning and performing the way that it's supposed to. Otherwise, you might be overheating material and causing quality issues. You might be losing capacity due to poor performance. So it's not just that avoidance of unplanned downtime. The way that you do your PMs, the routes that you do them, the scheduling that you have, are you doing them based on data-driven insights, or are you doing them because the OEM tells you to do it every 3 months? And kind of that hoping that you avoid problems because you caught it during the PM. You want to be able to reduce risk and operating costs. So if you can right-size your PMs and move an oil change from every 3 months to every 4 months, that reduces your risk of your employees, opening up a piece of equipment. It's less consumables, and you're not damaging your equipment in the process. So being able to do things like that, the operating cost in general, because that also feeds into sustainability, right? It's not just environmental sustainability, which most companies have initiatives around, but it's financial sustainability over the long haul. If you are able to right-size your inventory of spare parts, that's less cost, on the books for your company. So it's financial sustainability. And then really that convergence of IT and OT, of being able to take data from the OT network and share it across applications to really leverage data as an asset and turn it into insights for your organization. On top of that, how do you take a solution like this and scale it? So for large manufacturers, something that works at site 1 may not work very well at site 2 for a variety of different reasons. So how do you take a solution like PPM and scale it really across your entire operation from one location, but then across locations? Dealing with data silos. If you have different facilities with different SCADA systems, different data historians, how do you get data from a multitude of systems and be able to share it? The next is skills shortage. If you guys are like many of our customers that are having trouble in the maintenance teams, where the great retirement, right? They have a lot of, institutional knowledge that is retiring. How do you capture that? How do you institutionalize that and make it available to the next generation that's coming? You put new technology in, and it's only as good as the people using it, right? If you put it in, but nobody actually uses it, it provides no value. So how do you implement a solution that is worthwhile and you actually get value out of it? And then the last is just sharing that knowledge of best practices from site number 1 to site number 2, being able to collaborate and share that knowledge. For maintenance in particular, right, maintenance needs to be on the floor doing the work. They don't necessarily have the time or the skill nor the desire to do heavy, analysis. To become, a high-level vibration expert takes years. That makes you more valuable in the workplace. So you might, change jobs. So the company invests in an employee, they get the right skills, and then they take that skill set and go someplace else, right? And being able to, that knowledge transfer, how do you put it in a system, add context to it, add value to it, and then make it available to the next people that come in? And then that, dealing with the data silos, right, of being able to get data out of your OT network to take advantage of it and use it in a way that makes sense. So really, for the evolution of maintenance on the far left, it's reactive, right? You're running it to failure. You deal with it when it breaks down, and you don't put any extra effort or cost into maintenance. From there, companies have decided that's not a good way to do business because of the impacts that it can have. So they start to get better at scheduling the PMs, executing the PMs, having, data-driven insight into when they do the PMs, and it moves up the scale. So condition-based maintenance is really starting that, looking at vibration and doing an analysis and looking at the condition of the equipment. It can be a combination of online monitoring. So there's vibration tools that are out there that connect to a platform that you then have the ability either internally to do the analysis or by a third party that comes in through that dashboard and does the analysis for it. And then you start moving into the predictive. And now with like Industry 5.0 that's coming, it's moving into the prescriptive of having the system tell you not only that something's wrong, but what is wrong and how do you go fix it, right? So that's the prescriptive and prognostic side of where technology is starting to go. So if you look at your organization, where do you fall along that evolution, and where do you want to go as an organization, as a culture within your organization? So for us, kind of just expanding on kind of that evolution, Senseye this year is along the predictive. So Senseye has been around since 2014. We were acquired by Siemens in 2022 and then became fully part of the Siemens family April of last year. We've always been AI, machine learning driven. And this year, we have started to implement generative AI and co-pilot capabilities. And that's where not only are the predictions delivered to your team, but they're delivered with context. It's delivered with historical information already available to your team. And then through chatbot capabilities, so a co-pilot, you can ask the system questions. It's conversational. You can say, how relevant is this case to previous ones that you're referencing? So, pattern matching, you can ask it to translate it to Spanish because you want to take it on, print it out, and take it to a coworker. So really that wrapping all of that capability on top of it. So the co-pilot starts to interpret the data. So we've done a prediction. What is that data actually telling you about your piece of equipment? So it's that being able to not have to be a data scientist to understand what is going on with your equipment. You can ask questions, you can translate it. As you feed information into Senseye. So we've created a prediction in our environment. Your maintenance team goes out and performs maintenance. You've worked on the bearing, you've changed the oil, you rebuilt the equipment. If you feed that information back into Senseye, that institutionalizes it, right? It makes it available so that the next time that type of event happens, Senseye not only can identify you that it's happening again, but it can then deliver the context of this is the maintenance that you performed the previous time. This is where your maintenance team should start. So single source of truth, the Gen AI and the machine learning learns from these events. So it's an ongoing learning of the system that then makes that available to your team. So for Senseye, we combine two types of information. One is the condition indicator data, so that's your torques, your temperatures, your vibration. That data may come from IoT sensors. It may kind of originate in PLCs that go up through the SCADA system to a data historian. So there's a multitude of ways that we can get at that type of data. But then we combine it with the human knowledge. We want to know that you did maintenance so that we capture that, we learn from it, and then make that available to you in the future. So for us, we take a slightly different approach than some of the other PDM solutions that are out there. We create what is considered a unique fingerprint for each asset. And this is important because a pump at facility number one or location number one that's 5 years old may perform slightly different than a 1-year-old pump pumping different material, right? So the context, the operating context, what liquid is the pumping? Is it more viscous so it's easier? So the operating context combined with the condition indicator data combined with the maintenance feedback. So it takes about 100 hours of normal operating conditions to create the fingerprint. It's a configuration in our environment, so you don't have to have data scientists. You don't have to build and maintain models. It is all done automatically in our system. Once the fingerprint is generated, we then monitor 24/7 live data, so the condition indicators, back to and match that unique fingerprint. And any time that you deviate off of that normal running condition, we start to identify anomalies, trends, certain conditions that from that deviated norm. We then run it through an attention index to draw your maintenance team's attention to those assets that need the most immediate attention. And when I say attention, this is days and weeks or more advance notice that something is happening with your piece of equipment. You've had a step change. You might be still in normal operating conditions, but that step change is something for you to watch. It's something for you to go stand next to the piece of equipment, maybe watch it, see what's happening, and start to investigate why that step change has happened. You can put them on watch list. So the high means that eventually, if you do nothing on this piece of equipment, you're going to have a failure, right? You have a torque that's trending up. You haven't crossed a threshold violation yet, but it's trending that way, and it's going to continue unless intervention by your maintenance team occurs. So this is the Senseye interface. For us, on the left-hand side is your asset hierarchy. So when I call and use the term asset in our environment, we typically say that that's the lowest level that you would write a work order against. So it is directing your maintenance team to really that component, subcomponent of a larger piece of equipment. It gives you that visual indication of, high interest, low interest. It tells you what prediction caused us to create a case. So a trend, an anomaly, the name of the asset, where it's located for easy reference in your navigation. So when you have an asset highlighted, this window updates based on the prediction information. So your current had a trend that crossed the threshold at this point. So this right here is where the generative AI and the Copilot has started to deliver results for our customers. So it's giving you a very quick summary of why we raised the case and what the data is starting to tell you. So you don't have to go hunt for it. You don't have to go look, in multiple places for information. The second part down here is where we start to give possible explanations of what is actually happening with your piece of equipment. Mechanical wear, looseness. Here's a reference to a case that we previously identified. You can click on it. The system will take you directly to that case. So it's that context delivered for your maintenance team. This is a tool that is specifically designed for maintenance to log in, review information, make decisions with the maintenance planner as to when are we down 2 days from now, can this piece of equipment be limped along until that production downtime that is already there. And then from here, this is the Copilot capabilities where you down here, just like your chat GPT, start asking the system questions. It goes and queries into the system trying to answer it. It is conversational, meaning that you can ask secondary and tertiary, so you can have a conversation with it to further refine the results that the system is producing. Just recently, we added the latest technology for the Knowledge tab, which enables your team to be able to upload manuals, documentations, pictures are coming in the future. That documentation is fed into the generative AI and becomes available to the Copilot capabilities as well. So for us, we have multiple customer references. Our time to deployment is several months, so very quick. This is not a project or a technology that takes you 6 months to a year to get configured and deployed. So we have customers that have deployed Senseye and within 3 months are starting to get predictions that avoided downtime within 3 months. When we talk about scaling, the automotive manufacturer is now at 11,000 pieces of equipment. So your robots, your motors, your pumps, your blowers. They are in several different countries, so being able to work in different languages within the interface across time zones, etc. So a couple different examples. For us, and something I should have mentioned earlier, we are agnostic. We're agnostic to the industry. So a pump in the oil and gas industry is going to behave similarly to a pump in the food and beverage industry. We are agnostic to the asset type. So we don't concentrate only on rotating equipment, for example. That enables us to go and monitor equipment really across your production facility, into your utilities, your wastewater treatment, anything that has an impact on your production and your operations can be monitored in Senseye. It does require that we have data for it. So that is the one limitation is you do have to have data in order to feed into Senseye. The other agnostic is we are agnostic to the systems that are out there. So we are owned by Siemens, but we can connect to Rockwell, we can connect to ABB, we can connect to different data historians. So really, as long as we can get the data into Senseye, we can use it, leverage it, and start generating predictions for you. So for us, Senseye is a tool. It's an excellent tool to build a foundational PDM program around. Companies have to want to embrace the tool. They have to want to use it. So our goal as an organization is to have predictions that create value to your team, that are noticeable, they're documented so that you can go to management and say, we avoided 20 hours of downtime, which would have cost our organization $200,000. Whatever those metrics are for your organization and your operations. So really, it's creating a top-down, but also the bottom-up reliability culture. Really having site-level participation. So do you have somebody that is your PDM champion that helps drive use of the system, that helps drive changes in your processes to leverage the technology? So we were talking earlier, if you're doing manual route-based vibration analysis, that takes somebody physically walking around your facility to take the readings, to capture the readings, and then go back and analyze the information. That could take 2 hours, it could take half a day. Imagine putting that time back in somebody's calendar to go do other proactive activities for your organization. And that really switches you from cost avoidance, because you can't put that money back into accounting and go spend it someplace else. You've simply avoided, spending it. So it's that mentality shift to cost savings and being able to actually have your maintenance team saving the company money versus avoiding, the cost. So having champions, having that oversight from that higher level, organization side of things is where we've seen companies with the biggest success. Oftentimes, our customers start with an implementation of Senseye at one location. They'll start on a smaller scale to start understanding what PDM is, what it brings to the team, how to implement it into the team, and then grow it from there. Start those processes, learn those processes, and then start deploying more at scale. So really, we've also seen not only having those champions, but where are you guys in your data maturity? And so PDM does require a certain level of automation. It requires a certain level of data infrastructure, data connectivity to be in place in order to really take full advantage. With that being said, we've had customers start with us by sending us a CSV file of data. So it does not have to be that second and sub-second level of data, because we're looking at data over time, and we're doing that long-term analysis and predictions into the future versus today, right now. So sometimes there's that fine line between trying to capture something from an operational perspective, right? So you have a tank that needs to be at a set temperature of 100 degrees, and if it goes above 100 degrees for longer than 2 minutes, say, alarms start going off because you're damaging the equipment, or the product that you're making. So that kind of thing is more the operational side of things versus it being a true maintenance problem that you want to address when it makes sense to your production schedule. So the higher data maturity, and then that culture maturity, where you have program champions and organizational support, is where we've seen the best success for our customers. So starting to kind of wrap it up and why you would want to do PDM and picking tools. It's technology combined with your people. So PDM is really never intended to take people out of the loop. It's really about making you guys effective, precise, and efficient in when and why you do the maintenance that you do. It's data-driven insights that support making those decisions over time. So letting AI and generative AI support and do the data deep level analysis for you in an automated 24/7. I had one of my customers say Senseye was like putting his plant on cruise control, right? And it alerts you when something's going wrong. So from our perspective, Senseye, it is automatic. So none of our customers have had to hire data scientists. They didn't have to expand their maintenance teams. They did not let off or lay off any of their maintenance teams. So there's an initial configuration with the system, and then the system takes over and starts learning, and it's a continual learning. We also can scale across the different types of assets, and then across facilities, across regions. And this year, kind of that generative AI and co-pilot capabilities that are out in the marketplace now. So just a recap, the co-pilot capabilities is really allowing you to automatically ask the system questions. It goes and explores the data for you, returning the results to you, allowing you to get more information. Copilot allows you to go into the manuals and call up information as well. And then you can change the system over time. So for us, and this is the final wrap up, it's maintaining ahead of time of being able to look at the production schedule. When are your PMs? When are the plant turnarounds? When are the scheduled downtimes? To be able to be very precise about the maintenance that you perform during those times, and being able to go look at the inventory of spare parts. If you know 3 weeks from now that you need to have that motor changed, can you order it ahead of time and get it there on time instead of having it on your spare parts inventory? So a cost savings from that perspective. The reduction of operational cost. So the fewer times somebody has to go up on a platform, the safer your maintenance team is from that perspective. The capture of knowledge, just kind of again that summary repeat for many companies that are struggling with that wealth of knowledge that can easily leave because somebody gets a new skill set and goes to a competitor or to the plant just down the road, or the retirement of 30 years of maintenance experience, walking out the door and taking that experience with them, being able to capture it and then take advantage of it through tools like the generative AI, and then sustainability of helping from the sustainability. If your machine is not performing the way that it should, it could be consuming more energy. You could have leaks that you have to deal with from the environmental perspective, reporting to the EPA, for example. So supporting initiatives around sustainability. And that's it. I kind of ran through that. So more than welcome to take questions, comments from the audience. It's the predictive instead of preventative. It's just an acronym that they came up with.
So as far as the data being entered into the system, you have to remove all your manual routes. So you're saying everything would have to be automated, not like accelerometers for your vibration, which could also do your tap as well, depending on the accelerometer.
There's manual data that you can input.
If we were to say like loop samples, we get that information back from outside source. We have to put that into the Senseye, and that just keeps track of that for that asset.
Yes. Yeah. So we typically during the sales phase do a deep level workshop with our customers to determine what assets make sense to monitor. There's some that just aren't going to be valuable from a cost perspective. So we do the analysis of the asset, helping you build the business case for predictive maintenance and stuff. The second portion of that analysis is the data analysis. Our goal is to use as much of the data that you already have. So we're not going to come in with the assumption that we have to install a whole bunch of expensive hardware sensors, because there's a lot of data that already exists in PLCs and the data if you have a data historian. So we do that analysis. So we will look at the asset, we will look at the type of asset, and based on that, we'll determine these 5 data streams are a must-have in order to get predictions to it. These 4 data streams would enrich the predictions, meaning we can detect more failure modes and potentially give you a longer time frame for our predictions. So we do that analysis on what data type, data stream. So that's the temperatures, the torques, the RPMs, and go from there. So that's a long answer to your question, but not everything has to be automated. So there are some manual things that we could try to take advantage of.